Hello, in this video we will go over 2.4, the rational zeros theorem. The rational zeros theorem states that if we have a polynomial f of x, a general polynomial that has an integer coefficient and a's of n does not equal to 0, and if we have p over q is a rational zero of f, then p is a factor of the constant term a's of 0, and q is a factor of the leading coefficient a's of n. Now we're actually going to use this theorem. We're going to go ahead and find the possible list of rational zeros by finding these p's and q's. Okay, and how I will ask you on the exam will be something like this. I'll ask you to list all possible rational zeros, and I will give you a polynomial. Okay, so let's see. So what we want to find is we want to find all the p's first. Remember, p's are the factors of constant term. Okay. So the constant here is 10. So we're looking for factors of 10. So think of all the numbers that divides 10. And it can be either plus or minus 1, the smallest, plus or minus 2, because 2 also divides 10, plus or minus 3, no, not 3, not 4, but 5, and lastly, plus or minus 10. So these are the 8 numbers that divide our constant 10. Now for q's, we're going to list all the factors of the leading coefficient. And in this case, that leading coefficient is -2. Okay, so -2 right here. And again, it's gonna be still just either plus or minus 1. And what other number divides 2? Just plus or minus 2. That's it. So if we are looking for p over q, the list of all possible rational zeros, we're just going to write fractions. Okay, we're going to write, it can be plus or minus. Now what I'm doing is I'm dividing all these numbers, 1, 2, 5, and 10 by 1 first. So, if you divide 1, 2, 5, and 10 by just 1, it's going to be these numbers. Again, plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Now I'm going to divide all these numbers by 2 this time. So if you divide 1 divided by 2, you will get plus or minus 1/2. The next number, if you do 2 divided by 2, well, that's going to give you 1. And we have that listed here, so I don't have to list the repeated zeros. So skip 2 over 2. But we will do the next one. What's the next one? 5 divided by 2, we will have plus or minus 5 over 2. And let's check the last one. 10 divided by 2 is 5, and we have 5 listed here already. So we don't have to list the repeated ones again. So that's it. And this is it for our rational zeros. And looks like we have about, let me go ahead and try to highlight my answer. 1, 2, 3, 4, 5, 6. 6 times 2. 12 possible rational zeros. So this is what you do. I'll give you blanks for p's and q's, and you have to list the p over q's. You just have to make sure that you don't list the repeated ones, okay? Let's try 2 more, and then I'll ask you to try the classwork problem, okay? So p's and q's for this one. There are only 2 numbers that are actually important here. P's are going to be from the factors of the constant. So I'm going to look at all the numbers that divide 6. And q's are the factors of the leading coefficient. In this case, the leading coefficient is 2. So let me go ahead and write them down first, okay? So what are the p-values? Plus or minus. First number that divides 6 is 1. Next number, plus or minus 2. Plus or minus 3. And the very last one, plus or minus 6. So these are the 8 numbers that divides our constant term 6. Now next, let's go ahead and find all the numbers that divides q. That divides the leading coefficient of 2. And that's just going to be plus or minus 1, or plus or minus 2. So for our P over Q, we just have to write them in a fraction format. Well, I'm dividing everything by 1 first, so that will just be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And now let's do the fraction, okay? The first number, I'm going to divide 1 over 2. I'll get plus or minus 1 over 2. Next, 2 over 2. Well, that's just going to simplify to 1. 3 over 2, I don't have that listed already, so let me write down plus or minus 3 over 2. And the very last one, 6 divided by 2 is 3, and we have that listed there, so that was it. That's it for my list. And looks like I have, let me count them, 1, 2, 3, 4, 5, 6 times 2, 12 possible 12 possible rational zeros for this one again. Just checking if that, okay, that wasn't the same problem. Now let me do one more, and then I'll ask you to try the second page on your own, okay? All right, now this one, ooh, it's a little tricky one because as you can see, look, is this in standard form? I mixed it, so it's easier, I mean, for me to rewrite it in standard form. So if I rewrite this in standard form, I will have x to the third power first, with the one with the biggest exponent, minus 5x squared plus 7x minus 10. So here, the two numbers that are important to me are the negative 10 for my p's, the factors of the constants, and then, well, there's no number in front of x cubed. Well, you do know then it's just 1x to the third power. So that one's going to be simple. That's going to be all the numbers that divides 1. Okay, let's go ahead and list our P's and Q's, okay? So, P's, plus or minus 1, plus or minus 2. All the numbers that divides 10 evenly, plus or minus 5. And lastly, plus or minus 10. Okay, next one, all the numbers that divides 1. Well, that's simple, right? It's just going to be plus or minus 1. So, if I write P over Q, that's simply going to be all these 4, or I should say 8 numbers divided by 1 or negative 1. So it's just going to be the P repeated. Plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. That's it. So in this, I have how many? Let's count. I have 1, 2, 3, 4, 5, 6, 7, 8 different possible rational zeros that we can test using synthetic division, and we'll do that part in another video. But for this lesson, for this video, I want you to just practice writing the P over Q's, the list of all possible rational zeros, and what we just used is called rational zeros theorem, okay? Now let's take a look at what I want you to do for classwork grade. If you go down to page 2, this is it. I did post this on Canvas as like a separate assignment link. Rational zeros theorem classwork problems. I want you to copy or either copy or print this page, work on it, scan and submit it on Canvas by this Sunday at 11:59 p.m. and then I'll look at it, I'll grade it, I'll give you some feedback on it, and I'll use that as our first classwork grade for this week, okay? So let's take a look. I have 2 problems for you. F of x, everything is in standard form, so you don't have to worry about rewriting it. Give me P's, Q's, and P over Q's, okay? Now, number 2. Ooh, I scrambled it. You can see, what is the leading coefficient here? Leading coefficient is not 3. Leading coefficient is -5, right? And the constant is going to be -12. So that's going to give you, this -12 is going to give you all the P values. Well, you have to find all the numbers that divides 12. And you have to find all the numbers that divides -5 for the Q's. Now, that's it for classwork. I think I'm going to come back and record another video for 2.5, but that's enough for 2.4. The first, the rational zeros theorem that I wanted to go over before spring break. But I hope this video was okay. Email me if you have any questions, and please come back and check out the second video on 2.5 rational zeros. This will be uploaded very soon too. Thank you.